In this video, we'll be looking at some of the core ideas that classical approaches to decision-making get right. This is important because in later videos, we're going to be mainly studying behavioral approaches to decision-making, which emphasize all the ways in which people are not rational. But classical economics gets us surprisingly far with its assumptions of perfect rationality, helping us to explain why it is that a society of people who act in basically selfish ways nonetheless can lead to social order, a wealthy society, and reasonably good outcomes for most individuals. That is, if we assume that people are rational, we can make sense of the economy as a complex system. Remember that complex systems are systems of interacting parts that solve problems, and they get good at solving those problems by adapting. Thus, they have three properties: specialization, different parts of the system do different things; computation, they're solving problems by producing useful information as outputs; and evolution, they adapt to feedback from the environment. The mind is one example of a complex system that we talked about earlier. It's composed of parts. Brain areas are the hardware, and mental modules are the software. It solves survival-relevant problems, such as delivering information about the environment and allowing us to work together in groups. And it gets good at solving those problems through evolution by natural selection. Our ancestors all managed to survive and reproduce, and their less well-adapted counterparts did not. Now, we're going to see that the economy is another example of a complex system. First, economies are highly specialized. Different people and different organizations do different things. The Scottish economist Adam Smith and English economist David Ricardo worked out hundreds of years ago that it is specialization and trade that have allowed societies to become wealthy. If we had to produce everything for ourselves, we'd be very bad at doing any one thing. But because we can specialize, we can get very good at doing just a few things, and we can then trade with others. This specialization process makes everyone better off. For a fun illustration of the power of specialization, think of a product as simple as a toaster. As far as tech gadgets go, this is about as basic as it gets. But in reality, there's no one person who really knows how to make a toaster. You need miners to gather the iron ore, industrial smelters to turn it into steel, the petroleum industry to produce the oil that later gets turned into plastic by the chemical industry. You need engineers to understand how all these parts fit together, and you need designers to make the product pleasing to the eye and usable for a consumer. That's not even considering all the managers, administrative staff, custodial staff, and so on, who support all of these people and businesses. Not content to understand this only in theory, the British designer Thomas Thwaites decided he wanted to make his own toaster. He managed to get his own iron ore, he smelted it in a microwave, he made some plastic-like stuff, and he even figured out how to wire his toaster so that he could plug it into the wall. Less cool was that his toaster looked like this, cost him over £1,000 to make, and took him the better part of a year. Specialization and trade are the forces that, almost like magic, allow us to get what we want in an almost effortless way. As another example, think of a very minimal world that has just two people, Jane and Mary. Let's suppose they're each totally self-sufficient. Each of them might be able to make one loaf of bread, and they might be able to chop 3 logs worth of firewood. So if we look at this simple society overall, they have 2 loaves of bread and 6 firewood logs in total. But now imagine that Jane and Mary each specialize. They do just one thing, and they get really good at doing that thing. Now maybe Jane can make 10 loaves of bread, Mary can chop 30 logs in a day after they get a lot of practice, and acquire the right equipment. Now, society as a whole is much better off. It has 10 loaves of bread and 30 firewood logs, 5 times as much as when Jane and Mary were self-sufficient. Hooray, society is richer. But this isn't much use for Jane and Mary, since Jane is going to freeze without wood, and Mary is going to starve without bread. What can they do? Well, they can trade. If Jane exchanges some of her bread for some of Mary's wood, then they can both be better off than they were before. But most importantly, they're both much better off than they were when they were self-sufficient. Add up the power of specialization and trade for the billions of people in our world, and you start to have a sense of the power of the global economy, and why industrialization and globalization have been such powerful forces for making the world wealthier. This is all possible because the economy is a complex system in which we are each just one specialized part. Specialization allows society to make a lot of stuff. But how do we figure out where that stuff goes? That's what the Nobel Prize-winning Austrian economist Friedrich Hayek called the economic calculation problem. Hayek points out that no matter how much stuff we each have, we need to have a way to coordinate where that stuff goes. How do we figure out who needs bread and who doesn't, whether we're producing too many or too few logs, and coordinate production of those products with their inputs, like flour or saws? No one person has all the information required to make these calculations. But it turns out that the price system allows markets to solve these coordination problems without any one individual needing to know everything. How does it work? It goes back to Adam Smith again and his idea of the invisible hand. Smith proposes that there's a feedback loop among the demand for a good, the supply of the good, and the price of that good. When people want more of something, that usually causes the price of that good to increase, because there's competition among consumers for that scarce good. But the price is extremely important to information because it sends two signals. To consumers, it sends the signal to use less of that product, since it is now more expensive to consume. Consumers either consume less or satisfy that need with a different product. To suppliers, the high price sends a signal that this is a good time to increase production. As the available supply increases, this puts downward pressure on the price as the suppliers now compete with one another. Thus, we have a feedback loop that ensures that the amount of production matches the amount of consumption for any one good. As a concrete example, let's suppose we live in a simple world where trees only have one use, being burned to heat up houses. Let's say this economy produces 100 trees and the price is £5 per tree. But what if people discover there are other uses for trees? Trees can be used to build better houses for shelter, and they can be used to build furniture so we can be more comfortable. These are innovations that make people's lives better, but they're also going to place a strain on the production of trees. So what happens? The price of wood will increase. With this increase in price, suppliers might increase the number of trees that they harvest, so now we have more wood. But consumers are going to now look for substitutes for heating their homes. Other alternatives, like oil, may now become economical means of heating our homes, which may in turn put downward pressure on the price of wood. And this process continues as the system evolves. That brings us to our last point. The markets evolve. This is a process well understood by the Austrian economist Joseph Schumpeter. Schumpeter is famous for his concept of creative destruction, that changing markets are constantly destroying old firms and even entire industries while creating new ones. While this can be painful for individuals at a particular time, it allows markets to produce new, innovative products and for old products to get cheaper and cheaper to consume over the generations. It's why our generation is much wealthier than our grandparents' generation, who in turn were wealthier than their grandparents. What drives creative destruction? Signals sent by profits. A firm earns a profit when its outputs are valued by society more than its inputs. For example, Acme Inc. might take low-value inputs and turn them into high-value outputs. Acme will be a profitable firm, and that's because it's doing something useful for society. On the other hand, Pooptronics Limited might take high-value inputs and turn them into low-value outputs. Pooptronics is unlikely to turn a profit, and we actually don't want it to keep producing its products, since the longer the firm exists, the more value it is destroying. The profit and loss system helps society to reward firms that create value and prune firms that destroy value. But just as profits can destroy, so can they create. Because Acme is profitable, it gets to survive and to grow. Acme seems to have some good entrepreneurs and managers behind it, so they might figure out how to make other useful products. Some firms, like Ford Motors in the past or like Apple today, are highly innovative and have created many products that consumers prized. Moreover, when companies are profitable, Investors direct capital toward those companies, meaning that the most successful companies grow and can produce even more valuable outputs. But by the same token, the profits in this new industry attract more investors and entrepreneurs and encourage more innovation and risk-taking until there are many firms competing in the same market. That means that the prices of the outputs eventually decline, and this benefits consumers. To recap, one thing that classical economic approaches to decision-making get right is the roles of specialization, trade, prices, and profits. These forces help us to understand how economies are complex systems. Unlike minds, where the parts are different areas of your brain or different programs that your brain can run, the parts of markets are firms, products, and individuals who can specialize in different activities. Whereas our minds solve information processing problems, markets solve the economic calculation problem of getting resources where they can be best used through the price system. Evolution acts on individual genes to promote genes that aid survival and reproduction, helping successive generations of our ancestors to get better and better at solving information processing tasks. Likewise, markets harness the power of profit signals to destroy firms that are unproductive and reward firms that are innovative.